Data science mathematics refers to the mathematical foundations and techniques that are applied in the field of data science. It encompasses various mathematical concepts, methods, and algorithms that are used to analyze and extract insights from data. Data scientists leverage these mathematical tools to solve complex problems, make predictions, and uncover patterns and relationships within large datasets. Here are some key areas of mathematics that are particularly relevant to data science. 1. Statistics. Statistics plays a crucial role in data science. It involves collecting, analyzing, interpreting, and presenting data. Statistical concepts such as probability theory, hypothesis testing, regression analysis, and sampling techniques help data scientists make inferences and draw conclusions from data. 2. Linear algebra. Linear algebra is used extensively in data science for tasks such as matrix operations, vector spaces, eigenvectors, and eigenvalues. It provides a foundation for various machine learning algorithms, such as principal component analysis, PCA, and singular value decomposition, SVD. 3. Calculus. Calculus is important for optimization and modeling in data science. Techniques like gradient descent, which is widely used in machine learning for parameter optimization, rely on calculus. Calculus also enables data scientists to understand rates of change and perform advanced mathematical modeling. 4. Probability theory. Probability theory is the study of uncertainty and randomness. It is fundamental to statistical inference, machine learning algorithms, and predictive modeling. Understanding probability distributions, conditional probability, and Bayesian inference is crucial for making probabilistic predictions and decision-making in data science. 5. Optimization. Optimization techniques are used to find the best solution among a set of possible solutions. Data scientists often encounter optimization problems when developing machine learning models or when working with large-scale datasets. Mathematical optimization methods, such as linear programming, nonlinear programming, and constrained optimization, are applied to maximize or minimize objective functions. 6. Graph theory. Graph theory is useful in analyzing and modeling relationships between entities in a dataset. It provides a mathematical framework for representing and analyzing networks, such as social networks, transportation networks, or biological networks. Graph-based algorithms, like PageRank and community detection algorithms, are used for network analysis and recommendation systems. It's worth noting that while a solid understanding of mathematics is beneficial for data science, not all data scientists need to be experts in advanced mathematics. Many data science tools and libraries abstract away the complexities of mathematical implementation, allowing practitioners to focus on applying data science techniques to real-world problems. Dimensionality reduction. Dimensionality reduction techniques, such as principal component analysis, PCA, and T-distributed stochastic neighbor embedding, TSNE, rely on linear algebra and matrix operations to reduce the number of variables in a dataset while preserving the most important information. These techniques are used to visualize high-dimensional data and improve computational efficiency. Optimization algorithms. Optimization algorithms play a crucial role in machine learning and data science. They are used to find the best values for model parameters that minimize or maximize an objective function. Gradient descent, stochastic gradient descent, and evolutionary algorithms are optimization techniques commonly used in data science.